Hello and welcome to Rationals 3.3 Horizontal Asymptotes. Alright, today we're going to continue studying asymptotes. Last lesson we learned about vertical asymptotes. Today we're going to learn about horizontal asymptotes. Tonight's lesson is going to be a little bit more difficult though, because there's a lot more, understanding that needs to be involved with the figuring out of the horizontal asymptote. So hopefully it makes sense, and the explanation is hopefully pretty straightforward so that you guys can actually figure it out pretty easily. Okay, so when you start studying horizontal asymptotes, it's going to basically be a flat line, right? Because that's what horizontal means, right? It's a flat line basically, and it's going to be just like the vertical asymptote in the sense that the graph, when you start to draw it out, it's not gonna necessarily touch the horizontal asymptote. There's a couple of rare situations, not rare, but there's a couple of situations where the graph will touch the horizontal asymptote. So it's not going to be just like the vertical asymptote where it's never going to touch it. There's going to be a certain situation that exists in certain graphs that the horizontal asymptote will get touched. Yeah. So when we go and find where the horizontal asymptote is, though, you're going to have to evaluate things in the top and the bottom of the rational function. Okay, so when I say the top of the fraction, that means the numerator. When I say the bottom of the fraction, that means denominator. So that's why on this slide you see the letter N standing for numerator and the letter D corresponding to denominator. Okay, and when you do horizontal asymptotes, you're gonna find that they're gonna categorize themselves into three categories. Where in one situation you're gonna get the numerator value smaller than the denominator value. And in that situation, your horizontal asymptote is going to be y equals 0. Okay, that's this. Okay, this is where you got to remember. When you write the equation for a horizontal line, it's always going to be y equals a number. Okay, so please remember that. Right? Vertical asymptote was x equals a number. Horizontal asymptote is y equals a number. Okay, so if this is a situation that we have here on the far left, where your numerator number is smaller than your denominator number, your horizontal asymptote is y equals 0. Okay, if the number in the numerator is bigger than your number in the denominator, it's going to be a situation of no horizontal asymptote. Okay, and in the last category, if your numerator and denominator, the values that you're going to evaluate, are equal to each other, then you're going to grab your coefficients, or what is known as the number in front of the x, and you're going to divide them. And whatever that answer is when you divide your coefficients is going to be the number you're going to put after the equal sign. So it's going to be y equals whatever that number divided by is. Okay, and when you compare the number on the top and the bottom, I'll tell you guys more specifically what numbers we're actually going to compare to each other. But for now, just understand that you're going to compare a number that's on the top to a number that's on the bottom. And whichever scenario it fits himself into, that's going to be what your horizontal asymptote is going to be basically as you figure it out. Okay, so let me get to some live problems and you guys can see how it works. But let's look for some examples so that you guys can kind of see what's happening. So first thing I want to show you guys is what does a horizontal asymptote look like. And I guess I didn't draw an arrow, but I'll do that right now. And it's right there. Okay, it's that horizontal line that's in the exact same spot as the x-axis. So like I said the last lesson, we could have actually picked a better asymptote that you could actually see the dashed red lines, but since this is the parent function, the horizontal asymptote is at y equals 0. Okay, so there's pretty much no way around it. If I wanted to compare it to, or if I wanted to show you guys the parent function, which is 1 over x. Okay, so you can kind of see it if you look closely. Yeah, and like I said, yeah, we could have picked a better one, but yeah, we had to go with the parent function. Okay, next slide. Again, I mentioned this in the introduction as well, that unlike the vertical asymptote, where the line is never going to touch it, the horizontal asymptote, you're going to have some rational functions that are going to actually hit the horizontal asymptote. Okay, it's not going to be very often, but there's certain functions that when they form a certain type of graph, then they are going to make contact with your horizontal asymptote. Okay, all right. So here's what we do when we compare the numbers on the top versus the numbers on the bottom. We're going to actually look at the biggest power on the top, and we're going to compare that to the biggest power on the bottom. Okay, so when I look at the top of the fraction, I get 3x minus 2, so my biggest power is a 1. And now you can't see the 1, but there is a 1 right next to the x. Okay, it's just that it doesn't have to be written there because 3x, right, the standard number that's right next to a x that's all by itself is going to be pretty much a 1, right? And if it was supposed to be a power of 2, then you'd write a power of 2. If it's supposed to be a power of 3, you would write a power of 3. So if I don't have any powers written, the assumption is it's a power of 1. Okay, so my numerator number is a 1 because that's my biggest power on the top. My denominator number is a 2 because that's the biggest power on the bottom. So I'm going to compare the 1 versus the 2. Okay, and when I compare those two numbers, my conclusion is the bottom power is bigger. Okay, so if my bottom power is bigger, that means my horizontal asymptote is y equals 0. Okay, and that's all you got to do. You just got to compare the powers, and based on whatever category it fits himself into, then you get your answer for your horizontal asymptote. Okay, so let's look at another example. Okay, so let's look at our numerator's biggest power, which is a 2. Let's look at our denominator's biggest power, which is also a 2. So when I compare numerator versus denominator, I get same power situation. Okay, so when it's the same power, I'm going to grab what is called the coefficients. So coefficient is your number in front of the x. So on top, I have a 3 in front of the x. On the bottom, I don't see a number in front of the x squared, so I know it's a 1 by default. Okay, so 3 on the top, 1 on the bottom. So 3 divided by 1 is 3. So therefore, your horizontal asymptote is y equals 3. Okay, and this is for a situation where it's same power, right? We had a power of 2 on the top, power of 2 on the bottom. So that's the same power situation. So you divide your coefficients. Okay, in the third situation, we look at the power on the top, it's a 3. We look at the power on the bottom, it's a 2. So this scenario is top power bigger, right? Because 3 is bigger than 2. So when it's a top power categorization, then you don't have any horizontal asymptote. So it's no HA, no horizontal asymptote. So these are the 3 situations you got to memorize. And if you eventually do enough of these problems, you won't really have to memorize it. You'll just remember it. Yeah, but the thing is, yeah, you gotta just practice math. And not very many students out there like to practice math, but yeah, this is pretty much the best way to get these things into your brain. You just gotta practice it over and over and over again. Okay, so let's get to some live problems. And oh, actually, maybe not. I guess we have an example 4. Sorry about that. Okay, so top power is a 1. Bottom power is a 2. So the scenario that we are in is bottom power is bigger, right? Because 2 is bigger than 1. And if the bottom power is bigger, my horizontal asymptote is y equals 0. Okay? Alright, so now, still, we don't have a live problem yet. Okay, so top power is 3, bottom power is 2. It categorizes itself into top power bigger, right? Because 3 is bigger than 2. So there's no horizontal asymptote. Alright? And I think there's an example 6. Watch, there's going to be a problem. Oh, you know, it's example 6. Okay, so top power is 2, bottom power is 2. So this is a situation where we have same power, right? Because 2 and 2, they're the same number. So you grab your coefficients. So coefficient up top is a 4. Coefficient on the bottom is a 2, because that's your number in front of the x. So 4 divided by 2 is 2. So your horizontal asymptote is y equals 2. Okay? Alright, finally the live problem. So let's start to do these problems. So my biggest power on the top is a 1, right? I know I don't see a 1 next to the x, but because we don't see a number, your default is going to be a 1. My biggest power on the bottom is also a 1 because there's only x plus 4, so therefore the x has a power of 1 right next to it. Now I know I don't see a 1, but I know it's there, right? That's your default number if you don't see a power. So top is 1, bottom is 1, so this is a situation where we have same power. So this is same power categorization. So same power says you grab your coefficients. So you grab your numbers in front of the x. So the number on top in front of my x is a 2. The number on the bottom in front of the x is a 1. So I got a 2 on the top, I got a 1 on the bottom. So I'm going to grab those two numbers and I'm going to divide them. Okay, so you got 2 on the top, you got 1 on the bottom, you divide it, you get y equals 2. And that's your HA. So when you write your HA on this line, please make sure to remember to write it as an equation. because it's a line, it's a horizontal line. So hopefully back in your geometry days, you remember how to write equations for horizontal lines. Actually, I'm sorry, not geometry days, algebra 1 days, yeah? That you write a horizontal line with the letter y equals whatever the number is. So in this case, it's going to be a 2, so y equals 2. Okay? Alright, so let's look at problem number 2. So my biggest power on the top is a 1. My biggest power on the bottom, oops, did I write an N? I'm supposed to write a D, sorry. Okay, so the biggest power on the bottom is a 2. So 1 up top, 2 on the bottom. This is a situation where we have bottom power bigger. And bottom power bigger says, by default, yeah, your HA is y equals 0. Okay, so whenever your bottom power is bigger, your horizontal asymptote is y equals 0 all the time. Okay, so that's why you need to know these categories really well, because whatever category it fits himself into, then you just follow what the corresponding action is. So for same power in problem number 1, you divide coefficients. For bottom power bigger in problem number 2, your horizontal asymptote is y equals 0. Okay? Alright, let's look at number 3. So top power is 2, bottom power is 1. So this situation is top power bigger. And when it's top power bigger, your horizontal asymptote is, there is none, so no HA. So on the line you can write no HA, or you can write, yeah, let's just actually write no HA, no horizontal asymptote. Yeah, so whenever you have top power bigger, there is no horizontal asymptote. Alright? Okay, number 4. Okay, so my top power is a 2, and they kind of got tricky. They put the biggest power on the end, yeah? And on the bottom, our biggest power is a 2. So this is a same power scenario. And in same power scenarios, you're going to grab your coefficient up top, which in this case is kind of tricky, so be careful. It's a -1. That's your number in front of the x on the top. And your bottom coefficient is a 3, a positive 3. So when I figure out my horizontal asymptote, I'm going to divide my coefficients. So I got -1 up top, I got a 3 on the bottom. So there's your horizontal asymptote, -1/3. And don't forget, don't just do this, because I see a lot of kids doing this all the time. They just write the -1/3 there. And when they write that, I cannot give you full credit, because this does not tell me the location of the horizontal asymptote if you just write -1/3. You got to write y equals -1/3, because it's a line, it's a horizontal line. And that's how you express horizontal lines, as a y equals a number. Okay, so don't forget about that. Alright, is there a problem number 5? No, there isn't. Okay, your next problem is homework. So, good luck on this assignment. I will see you in class. Bye-bye.